Let us first take a look at the input file quickly. It is stored in HDFS. I downloaded from the Wikipedia website by curl command and then use HDFS put. As you see, the first column gives us a project, wiki project's name, and then there's a web page, and my task in this project is to find a special pattern that starts with the user prefix colon and then the name, and the last column is the page count here. So this is how our file looks like. Let us look at the source code for our first client, which is Wikipedia Extractor. It's a Apache Spark application which reads the data, it does the filtering that we mentioned about, aggregates the hits per user, saves it to an RDD object, and from RDD we're going to publish the data to a channel, Redis channel, using the PubSub protocol. So the code structure is reminiscent of the homework 10, where we did a Bible word count. So I have my validation or reporting functions as like logging main milestones, minor milestones for making sure that I see the progress there. And nothing new here. Nothing new here. We check the input file and output directory in HDFS to make sure that they exist. If the output directory exists, we remove it, like we did in the assignment. We have a helper function called splitLine. What it does is to reads every line and then creates an array using the page visited and the hit. And then there is another helper function is called is user related. What it does is it looks at these prefixes, either capital or small case, in every page, and returns true if this value contains that specific keyword. Then we flag them as users, and these are the only data that we want to utilize. And we use this function in the filter is user related, as you see. And then we have this flat map that refers to split line that I talked about. Reads all the lines, and creates those arrays of two members. And our mapper will get the value on the left and right, that is to say, our user and hits, thanks to our filter and pre-mapping function, and do a certain reduce by adding all the hits per user. I save the result to a file for debugging purposes, and then comes the interesting part. Python has a library for Redis, PyRedis, where you import this library easily. As you see, I made some tests with streaming context after last week's lecture, but this one doesn't use streaming for the demo. If you go back to our Redis object, we create an instance of it, and then we ping the server if it exists or not. It's localhost. Otherwise, we print a line. And then we have a support function. So what it does is it goes through the counts collect array. So RDD is converted to a list. And for each item, it applies this AX function. What does this function do? It gets the instance of this Redis object and does a publish to the channel user's channel, sending a white space separated input. On the left side, as we said, user, and then on the right hand side, the page count. So this is what the extractor does. Then we have another code whose name I forgot. It's user cacher, which is another Python application which uses Redis client, and it doesn't have any HDFS functionality. What it does is, okay, we have the login functions. It has a callback function for user event handler. I'll get back to this soon. And it has this Redis object that we connect to. It's exactly in the same fashion. Then what we do is, by using the pub/sub function, we create an instance of this pub/sub class, and we let our clients register this user with a callback function reference back to user event handler. And we said that we're listening to the channel. And then it loops until we press Ctrl+C, but it sleeps for a while, so that in each control it checks if there's a message or not. And if there's a message, this callback function will be triggered. When callback is triggered, we say like, okay, data received. We just display it on the output. And then we split the data because it consists of two entities, as we showed in the earlier code, username and user score. And what we do is we added that to a sorted set, which is a perfect structure for us to keep track of leader lists later on in the Redis database. So it will update a key, but it will add all the users to this sorted set. And now I'm going to show the Java code, which is called user analysis. As I explained in the first part of the presentation, we use different sets of tools to access Redis, and the library that we use is called Jedis, although I would prefer to call it Jedis due to my certain Star Wars obsession. So from now on, I'm going to call this library Jedis. As you see, a subtle reference to the Star Wars. What this class does is, let's look at the main method first. So far, we have an extractor that publishes messages to the bus. And there's a listener that retrieves those messages, Python code, and updates the sorted set in the Redis database. What this component does is that it doesn't listen to pub/sub channel, but what it's interested in the current state of the key user score, which is user score list, which was updated by the previous client. And as I said, I say previous client, but it's kind of a simultaneous stream, but I'm referring to the order of presenting my code. As you see, there's a graphical interface code here. Actually 80% of the code is graphical user interface. When we start program, the users ask for a dialog. How many top users would you like to see? And we create an instance of the user analysis object. And then in this object, we make a reference to the Jedi's object by localhost in the same fashion as we did in Python. We verify it's working. And then we get a tuple set of tuples from this function, reverse range with scores, which gives us a list of desired count items -1 from 0 to -1. If you submit 100, it's going to right, like 0 to 99. And we want to retrieve 3 items. First of all, ranking, and then username, and number of hits. Default table model is a Java-specific class to fill JTable. I won't delve into the details. And for each object, we create a rank is the iterator, so it's like 0 starts with 1, 2, 3, 4, 5, for all the elements. And we write the score and the tuple's name. And we then run a different function that's called zcard. It gives us a list of members in the set, and we create a user design UI called wiki demo, and we're going to see that this is going to display X users, which are given by the interface earlier by J option pane, and out of this number of users, which was retrieved by zcard function, and there'll be, and the data will be fed into JTable. As I said, the code is 90% UI. Now we take a break and come back right away with the demo itself.